Good morning, all of you. Welcome back to the YouTube channel Arkeys Electric World. So, in last lecture, we have started the second unit under Basic Electrical Engineering, that is DC circuit, and we have discussed about the Ohm's law in last lecture. So, in today's lecture, we are going to discuss everything about the resistance. What is the resistance, and each different factor resistance is dependent, and what is the specific resistance. So, let's start with the concept of resistance. So, in last lecture, that is under the fundamental of electrical engineering, we have discussed this concept. So, just go thoroughly about this. So, here we have considered one conductor, then supply is provided, that is voltage V is applied, and due to that, the current is flowing through this conductor. So, free electrons flows from negative ends to the positive ends, and during this travel free electrons faces opposition from another atoms or nucleus. So during this travel the electrons collide on another atoms, but still it's completes its path from negative end to the positive end. So opposition offered free electrons is a property of that substance, and this opposition is nothing but the resistance of that substance. So what is the resistance? That meant is that resistance is the property of substance due to which it opposes the flow of the current through it. So it is simply a property of substances which opposes the flow of the current, and that flow of current is nothing but the flow of electrons, which in details we have discussed in the concept of electrical conductivity of conductors. So this one is the symbolic representation of resistance. Simply to understand the concept of resistance, you can take the example of that is breaker that is available on the road. So this only reduces as like breaker reduces the speed of the vehicle, same as it is the flow of electrons is controlled by the resistance, and this is the symbolic representation of resistance. And unit of resistance, that is nothing but the ohm. So resistance is different for the different material. So let's understand. Already you have discussed about the material. So different nodes for the particular material like the conductor, insulator, and semiconductor. What is the relation, or what is the value of that resistance? How it changes from material to material? Let's discuss that. So material resistance of material is different material to material. So first one, for metals, or we can say the conductor, substances like the metals copper, silver, aluminum offers a less opposition to the flow of the free electrons. So these materials is having the less resistance, like the conductor material having the less resistance. Second, substances like the insulator, means that examples are rubber, plastic, glass, offers very high opposition to the flow of free electrons through it. That is, these materials have very high resistance. So it offers the maximum opposition to the flow of the free electrons, means that it's having the high resistance in an insulator. Then third one, substances like the semiconductor, that is the silicon, germanium, it offers a medium opposition to the flow of free electrons. So material is having the moderate resistance. Simply conclusion is that resistance offered by different material order. So material metals is having the less resistance, means that is offer the less opposition to the flow of the electrons. Second, the semiconductor is having the moderate resistance, and insulator is having the maximum resistance. Okay. So what is the ohm, 1 ohm resistance? So 1 ohm resistance is nothing but a wire said to have the resistance of 1 ohm. So we can say the wire is having the 1 ohm resistance if potential difference of 1 volt across its end causes a 1 ampere current flow through it. So simply we can say the material or wire is having the 1 ohm resistance if we provide the potential difference of 1 volt across its two ends, which causes the 1 ampere current flow through it. So we can say that that wire is having the 1 ohm resistance. So on which different factor the resistance is dependent, let's discuss. The factors on which resistance of conductor dependent, that is first one is nothing but the length of conductor, second one area of cross section of conductor material, then third one type and nature of conductor material, and last one that is the temperature. So let's discuss one by one the factors on which the resistance of conductor depends. So first one is the length of conductor. So resistance of conductor material is directly proportional to the length of particular material. So that is, we can say R is directly proportional to the length L. This means that the longer the length of conductor material, greater the resistance. So here we have considered the two copper wire having the length of L1 meter and L2 meter simultaneously. So copper wire in which the length of second material that is having the L2 meter. So as we said, the resistance is directly proportional to the length of conductor. So this means that the longer the length of conductor material, greater the resistance. As length of particular conductor get increases, it will increases resistance of that particular material. So R is directly proportional to the length L. Second factor, that is nothing but the area of cross section of material. The resistance of conductor material is inversely proportional to the area of cross section of the same material. So here resistance is inversely proportional to the area. Again we have considered the two copper wire having the area A1 meter square, and second copper wire is having the area of A2 meter square. So here the resistance is inversely proportional to the area if the area of that particular conductor get increases, lower the resistance of that particular conductor. So if the area of conductor get increases, it will reduces the resistance of that particular material. So it is a inversely proportional relation to the resistance. Then third one, that is the types and nature of conductor material. So the resistance of conductor depend upon the nature of material of which it made. So the from which material your conductor is made of, depending upon that also the resistance is variable. So already we have discussed for the insulator, semiconductor, conductor. So some materials have the low resistance, whereas the other having the high resistance. So insulator is having the maximum resistance, conductor is having the less resistance. Here example is given for the silver. Silver has a low resistance than the iron. And last factor on which the resistance is dependent, that is nothing but the temperature. Temperature affects the resistance of conductor material. In most of the conductor material, resistance increases with the temperature. So here resistance of particular material get increases with the increase in the temperature. How this increases, just let's discuss. As temperature of conductor increases, free electrons increases, but due to thermal vibration, opposition to the free electrons is also increases. This means that resistance increases with temperature. So these are the different four factors on which the resistance is dependent. So by concluding these all the four factors, mathematically we can express the resistance, that is we can say R is directly proportional to the length L, is R is inversely proportional to the area A. So we can write R that is directly proportional to the L by A. So replace the proportional sign with the proportional constant. So to remove the proportional sign, take the constant, that is nothing but the rho. So R is equal to rho into L by A. So here rho is the proportional constant called as the resistivity or specific constant. So here is the rho is nothing but the specific constant, or you can say the resistivity. So what is the concept of this specific constant or resistivity? Let's understand. So specific resistance or resistivity, we have seen that the R is equal to rho into L by A. So here assume the value of length L is equal to 1 meter and area A is equal to 1 meter square. Then we can say that R is equal to the rho, that is the resistance of particular material is equal to the resistivity. So what is the definition for the specific resistance or resistivity? The resistance of specimen piece of material having the unit length and unit cross section area is known as specific resistance or resistivity of that material. So specific resistance or resistivity is nothing but the simply resistance of that particular material, but there is condition is that having the unit length and unit cross section area, it is called as the specific resistance or resistivity. So here the resistance of the specimen meat piece of material having the unit length, here length is considered 1 meter and having the same length is 1 meter and area is 1 meter square. So what is the unit of the specific resistance? So we know that the R is equal to rho into L by A. So we can write rho is equal to R divided by L by A. So simply rho is equal to R into A divided by L. So we know that the unit for resistance, that is nothing but the ohm. Area, it is measured in meter square and length is meter. So simply the specific resistance is having the unit, that is nothing but the ohm meter. Okay. So this is all about the today's lecture. In next lecture we are going to discuss about the energy sources. So what are the different energy sources in the circuit, that we are going to discuss in the next lecture. Thank you.